So today we're going to answer exercise 1.35 under chapter 1, section 1.8, components of vectors. Okay, in the problem for the vectors A and B uh in this figure E1.28, use the method of components to find the magnitude and direction of vector sum A plus B, the vector sum B plus A, and the vector difference A minus B and B minus A. So to answer this, let's answer first letter A. Okay, we're gonna use the same method that we used in our previous videos. So we have the magnitude, which is 8.0 meter, and we have for B, which is 15.0 meter. So we have an angle from the uh, from the positive x-axis. Okay, from the positive x-axis to the vector. So we have for A, we have 270 degrees, and for B, we have 60. So for B, we have 90 minus 30, we have 60 degrees. 60 degrees. And we have X component, and we have Y component. Okay. Okay. So we have Y component, X component. So for our X component, so our AX is just 8.0 meter cosine of 270 degrees. So 8 cosine 270 is 0. So we have 0. And we have 8 sine 270 is negative 8. So we have 8.0 meters. So our AY is negative 8.0. 8.0 meter sine 270 degrees. Negative 8 meter. And this one is 0. So for BX, so we have 15.0 meter cosine of 60 degrees. So we have 15 cosine of 60. So we have 7.5 meters. So for BY, we have 15.0 sine of 60 degrees. 15 sine of 60. So we have 12.9, 12.99 meters. Okay, so here, I mean, so I was wrong about this again. Okay. So we have here negative 8.0 meters, and we have here okay 7.5 meters, and we have 12.99 meters. Okay, let's answer for letter A. Uh, this one is the Rx is just A plus B, or AX plus BX. So we have 7.5 meters, and here and RY is 8 minus 12.99. So we have 4.99 meters. Okay. So this is for A plus B. So for uh, vector A plus B, okay. So for vector A plus B, so we have, for example, we let this to be equal to vector D, okay. And our dx is equal to ax plus bx. So we have 7.5 meters. And our dy is ay plus by. So we have 4.99 meters. Okay. So to find this angle, okay, to find the vector a plus b, so we have positive positive dx, and we have y, and this is x. We have positive dy, okay, dy. So this is our vector components. This is our vector d, the sum, which is a plus b. Okay. So the magnitude. So we can find the magnitude of this. For example, this vector d that we let as a plus b is just equal to 7.5 meters squared plus 4.99 meters squared. So the magnitude is the square root of 7.5 plus 4.99 squared. So 9.001 meter. So the theta, if you want to find the angle theta here, theta is equal to the tangent negative 1 of this rx over ry, or ry over rx. Okay. So our ry is actually tangent to the negative 1 of our ry, which is dy, which is 4.99 meter and 7.5 meter. It will give us shift tangent of 7 point, so 4.99 over 7.5. So the angle is 33.6. So theta is 33.6 degrees. So theta here is 33.6 degrees. And our a plus b magnitude is this one. Our magnitude of our vector d is 9.001 meters. So that's for letter A. So for letter B, okay, for letter B, so we have our D is equal to B plus A, okay, where our dx is equal to bx plus ax, and our dy is equal to uh, by plus ay. Okay. So our bx is 7.5 plus 0.0 meter, our ax, and here we have 12.99 meter plus the negative 8.0 meter. So we will have again 7.5 meter, and we have 4.99 meter. If you want to find the magnitude of this d again, the magnitude of this vector, so we have dx squared plus dy squared, which is the same, which is will give us 9.001 meter, and this theta is also tangent to the negative 1 dy over dx, which is also 36.33.6 degrees. Okay, the same answer for letter A, since because a plus b is just equal to, because b plus a is just equal to a plus b. Okay, so these are one of the properties of addition of vectors. Okay. So for for letter C, okay, for vector for C, okay, so let our vector D is just equal to vector A minus B, where dx is equal to ax minus bx, and our dy is ay minus by, So we have, so, so our AX, ano ba yung AX natin? 0, and our BX is, so 0.0 meter minus 7.5 meter. Ito yung BX natin. So we have negative 7.5 meter. And then our AY, ano ba yung AY natin? AY natin is negative 8. Tapos BY natin is, so negative 8.0 meter minus, this is minus 12.99 meters. So we have 8 minus, we have negative 8 minus 12.99. So it will give us negative 20.99 meters. So if you're going to sketch this one, so it is in the third, we have negative dy, and we have positive, and we have negative dx. Okay, negative dx. Okay, so our vector d is along this direction. That's d equal to a minus vector b. So here, the magnitude of our vector d is just equal to the square root of 7.5 meters squared plus negative 20.99 meters squared. Okay, that's the magnitude. Square root of negative 7.5 squared plus 20.99 squared is, so we have the magnitude is 22.3 meters. Okay. So if you want to find the angle theta, so the opposite of the angle is dy, and the adjacent is the dx. Okay. So the tangent of this theta is equal to dy over the opposite over the adjacent, or the theta is just equal to tangent to the negative 1, which is dy, which is negative 20.99 meter over negative 7.5 meter. Okay. So shift tangent, so tangent negative 20.99 over negative 7.5. So we have the angle of theta is 70 degrees, 70.3 degrees. So that the direction is north of, uh, south of, west, or 70.3 plus 180, or 250, or the angle here is 200, the angle here from there is 250.3 degrees, which is 180 degrees plus 70.3 degrees. So that is the answer for that. Okay. How about for letter? So for letter D, what is the answer for letter D? Okay, so to answer letter D, okay, so let our D, vector D is B minus A, where dx na to is just bx minus ax, and our dy is by minus ax. Okay, so we're gonna switch this one, 7.5 minus 0, 7.5 meter minus 0, and we have here, so we have 7.5 meters, and switch this one, 12.99, so 12.99 minus negative 8.0 meter, so we have, so So 12.99 plus 8. So we have 20 point, so 20.99 meters. Okay. If we graph this one, both are positive. So we have our dy, we have our dx, this is y, this is our x. So meaning our vector d is from that direction. Vector d is in this direction. So unlike this one, so our vector d is in the opposite direction. I guess this the exactly opposite direction of this one. The same magnitude, the magnitude of our d is also 22.3 meters. So using this one, and the theta, okay, the tangent to the negative one. So here the Rx is dy. I mean, this is actually dx and this is actually dy. So the opposite is dy over dx. Okay, so here the angle is uh, the same also, which is 70.3 degrees. But the direction is now north of east. Shift tangent, tangent 20.99 over 7.5. So 70.3, but the direction is north to west. Comparing to the our answer for this one, so this is in the direction completely opposite direction. So it says that our so states that our b minus a is just equal to the negative of a minus b. So this is properties of addition of vectors. So we confirm this using components of vectors. So thank you for watching, everyone. Please click the subscribe button, leave a comment, and like our video if you want more videos like this.